Hello everyone, this is Mlinden Ulu as it is written on the screen. Guys, today I'd like to take you up on the kinematics in one dimension. So on kinematics in one dimension, we have different things. We have the definitions. When we are talking about the kinematics in one dimension, we are talking about the motion that moves along a straight line, which means it moves along the x-axis. It can go towards the east, it can go toward the west. Okay. We also have the physical quantity and the scalar quantity. As we all know that the scalar quantity is the physical quantity that have magnitude only, and the vector quantity is the physical quantity that has both magnitude and the direction. So please note that there's difference between the scalar quantities and the vector quantity. We also have the displacement. The displacement is the shortest distance from the initial position to the final position. So guys, I also contributed some few examples there which will explain further about the kinematics. On this one, on the first picture, we have the kinematics equation. As the lecturer Mr. Mbanza taught you today, that there are three major kinematics equations. We have the first equation of motion, which states that final velocity is equal to v naught or v initial plus acceleration times time. We have the change in x, we have the change in x. So they separated it into x final minus x initial. So and then they transpose the x initial on the right side. So we have x is equal to x initial plus v naught t plus 1 over 2 at squared. We have the third equation, you state that v squared is equal to v naught squared plus 2a. Change in x. Change in x, we know that change in x is equal to x final minus x initial. Okay, these are the three major kinematics equations that can be used to describe the motion. Okay, these equations, as the lecture states, that they are all used when the acceleration is constant. If the acceleration is constant, we can say that our acceleration is constant when it is equal to 0 meters per second squared. Okay, we also have the final equation, which can also be derived from the above equation. We say that velocity is equal to v initial plus v naught all over 2, or you can say that average velocity is equal to 1 over 2 v plus v naught. On the scalars, and vectors, as I explained above, that a scalar, it has only the magnitude. A physical quantity that has only the magnitude, and vector quantity is also a physical quantity that can be used. It has both magnitude and direction. Here guys, you are given the examples of the scalar quantity as well as the vector quantity. We know that length is measured in meters, is a scalar. We have area, we have volume, we have speed, we have mass, we have density, we have pressure, we have temperature, we have energy, entropy, work, and power. On the vector quantities, we have displacement, we have the direction, velocity, we have the acceleration, we have momentum, as we did it in grade 12, P equals mv. We have the force, we have the lift, drag, thrust, weights. Finally, on the displacement. As I explained, that the displacement is the shortest distance from the initial position to the final position. So from point A to point B, this is our displacement because it is the shortest distance from initial position to final position. And we have the distance that distance is the total distance that traveled by a particular object. So as we see that you have the dotted lines here which represent guys, as I was still explaining that still explaining the distance, the difference between the distance and the displacement. I also contributed some examples that is written on my handwriting. Here I draw it on the paper. Then we have the x change in x, which is equal to x final minus x initial. We have the equation of the average speed, which is as we know that the average speed is the rate of change of distance, and the average velocity on this side we have is the rate of change of displacement. And then here I made an example. We have the object which moves toward the east. It's move on a particular distance of 100 meters. And then I also have the object that moves towards the west direction. It's moved 150 meters direction. The time is given is 5 seconds. And then in this case, we can calculate the average speed using the equation that average speed is equal to distance by time. The distance in this case will add the distance because speed is a scalar quantity. So we'll say 100 meters plus 150 meters, then we get 250 meters. We're given the time that is 5 seconds. The object travel 5 seconds. So we got the final answer that is 50 meters per second. On the average velocity, as I said, that average velocity is a physical quantity that have both magnitude and direction. So I indicated my direction here that towards east, I choose that direction to be positive. And then I also write this in B to show you that this is important. I have the object that moves towards the east at 100 meters. I also have the object that moves towards the west at 150 meters. So this negative indicate the direction. That's as I said that I choose east as positive, which means west is negative. And then you can add it together, then you can get 50 meters all over 5 seconds. And then you got the answer. So average velocity is equal to minus 10 meters per second. So at the final answer, I remove that negative because west will also represent that negative. That negative represents the direction that the object is going towards the west. So that's why at the final I just write west. That one is the final one that I did today, guys. We have the instantaneous velocity. Instantaneous velocity is the velocity that is the velocity at an instant of time. Okay, we know that the average velocity is the rate of change of displacement. As we know that the displacement is x final minus x initial all by time. So the instantaneous velocity will become average velocity is equal to limit as change in t approaches 0, change in x by time. On a constant speed, we can expect to have something like this. This is the equation. D is equal to D. This is the distance is equal to speed times time. So in this case, as Mr. Mbanza said, that the speed is equal to average velocity in this case because the velocity is not changing. The velocity is constant. Therefore, we can conclude that the speed in this case is equal to the velocity. Then let's finally speak about the constant acceleration. On a constant acceleration, we still have the displacement, which is equal to average velocity times time. Okay, in this case, the speed is not equal to the average velocity. Whenever there is acceleration, that means the velocity is changing. Yes, once we have acceleration, then the velocity is changing. As we know that the acceleration is directly proportional to the velocity. So if there is change on the velocity, obviously there will be a change on an acceleration. These are the equations. Thank you.